Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate the orthographic projections of a line which happens to be inclined to the horizontal plane and parallel to the vertical plane. Now since this line happens to be parallel to the vertical plane, so its projection on the vertical plane will reveal the true length projections of the line in the front view projections, whereas this line happens to be inclined to the horizontal plane. Therefore, its projections onto the horizontal plane, that is the top view projections, will reveal the apparent length projections or the shortened projections onto the horizontal plane in the top view projections. The straight line LM 40 mm long, it happens to be parallel to the vertical plane and inclined to the horizontal plane at an angle of 40 degree. The end L of the line, it is located at a distance of 25 mm above the horizontal plane and 10 mm in front of the vertical plane. So we are required to draw the orthographic projections, that is front view, top view and the left hand side view projections of this particular line LM. And besides this, we are also required to locate the traces of the line LM with the reference planes horizontal plane and the vertical plane. So let us first of all obtain the spatial location of this particular line LM with respect to the three reference planes, that is horizontal plane, vertical plane and the profile plane. So here we have constructed the horizontal plane, the vertical plane and the intersection of the horizontal plane and the vertical plane will provide us with the XY reference line. And now here we know that this line LM, it happens to be parallel to the vertical plane and this line LM, it is inclined to the horizontal plane, and this angle of inclination of this line LM with respect to the horizontal plane, it happens to be 40 degree. That is, this angle of inclination of the true length LM, which measures 40 mm with respect to the horizontal plane, it will be denoted by angle theta, and this angle theta, it is equal to 40 degree. And we also know that the coordinate location corresponding to one of the ends of this line, that is end L of the line, it happens to be 25 mm above the horizontal plane and 10 mm in front of the vertical plane. So we can locate this particular line LM with respect to the two reference planes, that is horizontal plane and the vertical plane, as it has been shown over here. Now whenever the observer is going to view this particular line LM from the front side, so we are going to obtain the true length projections of this particular line in the front view projection. That is, the front view projections obtained on the vertical plane, they will reveal the true length projections of this particular line LM. Why? Because this line LM happens to be parallel to the vertical plane. So therefore, the first of all, the projections which will be obtained corresponding to this line LM will be L dash M dash, and this L dash M dash projections, they have been obtained in such a way that these front view projections, they will provide us with the true length, that is 40 mm length of this particular line, right? So this way the front view projections of this line, they have been obtained. Now when an observer is going to look at this particular line LM from the top, so we will find that we are going to observe the shortened projections of this particular line LM onto the top view projections, which will be obtained on the horizontal plane. The reason why this shortening occur, because of the angle of inclination of this line with respect to the horizontal plane. So we are going to view the foreshortened view of this particular line onto the horizontal plane. So these projections, that is LM, which are obtained on the horizontal plane in the top view projections onto the horizontal plane. So these will be called as apparent length projection. So apparent length projections, so basically they are the foreshortened projections of a line corresponding to a line which happens to be inclined to that particular reference plane. So having obtained the true length projections of the line in the front view, the foreshortened or the apparent length projections of this particular line LM in the top view projections, now we have to establish the relationship between the front view projections and the top view projections by drawing these two construction lines over here. So once we draw these two construction lines corresponding to the point L, so we will be able to obtain the correlation between the front view projections and the top view projections corresponding to the point L. Similarly, once we draw these two projection lines corresponding to the front view and the top view projections corresponding to the point M, so we will be able to establish the correlation or the interrelationship between the front view and the top view projections of this particular point M over here. Now another thing we need to work out over here is the traces of this particular line. So we know that since this line LM, it happens to be parallel to the vertical plane, so this line LM, it is not going to intersect with the vertical plane at any given point of time. So since this line LM doesn't intersect with the vertical plane, so there will not be any vertical trace corresponding to this line LM, and this line LM, it is inclined to the horizontal plane. So this line LM, when extended, it is going to meet horizontal plane at certain point of time. So please check, is this line itself intersecting with the horizontal plane? Answer to this question is no. So since this line doesn't itself intersect with the horizontal plane, so what we have to do in order to obtain the horizontal trace of this line, so we need to extend this particular projection of the actual line LM with respect to the horizontal plane. So the moment we extend this line LM, which is inclined with respect to the horizontal plane, so we will find that the extension of this line LM, it is going to intersect with the horizontal plane at this particular point. So the name of this point will be point H over here. So the moment we obtain this point H, which is the point of intersection of the extension of this line LM with the horizontal plane, so now we are going to draw the perpendicular projection from this point of intersection of the extension of the line LM with the horizontal plane, and this perpendicular projection, once it meets the XY reference line, we are going to obtain the point H dash, which otherwise it is the extension of the front view projection L dash M dash corresponding to the line LM. So if we extend this line L dash M dash, so it is going to converge or it is going to meet the XY reference line at the point H dash over here. So this perpendicular distance between these 2 points H dash and H, it is going to deliver us the measurement of the horizontal trace of the line. So this measurement will be equal to 10 millimeter. So we work out that the horizontal trace of the line will be 10 millimeter in front of the vertical plane. So this way we have been able to evaluate front view true length projections, top view apparent length projections, besides evaluating the horizontal trace location of this particular line LM. Now let us proceed with the construction of the side view projections corresponding to this line LM. So here we are required to evaluate the left hand side view projections corresponding to this particular line. That is, the observer is going to look at this line LM from the left hand side. So the projections of this particular line LM will be obtained on the profile plane which is located on the right hand side. So now once we draw the projections through the points L and M onto the profile plane, so we find that since this line LM, it happens to be inclined to profile plane as well, so the projections of this line LM onto the profile plane will be foreshortened length of this line onto the profile plane. So we are going to obtain the apparent length or the foreshortened projections of this particular line LM onto the profile plane. So the projection through the point L, we can see this is projection L double dash. Similarly, when the observer is looking at the point M, so point M will be projected over here at this particular position onto the profile plane. So this point name will be M double dash. So now having obtained the 2 points L double dash and M double dash onto the profile plane, now we can join L double dash with M double dash over here. So this projection L double dash M double dash projection which has been obtained onto the profile plane, so it reveals the apparent length projection of the line, that is the foreshortened projection of this particular line LM in the left hand side view. So this way we have been able to obtain front view projections, top view projections and the left hand side view projections onto the 3 reference planes, right? So now we have to establish the relationship between the front view projections and the left hand side view projection. So please check, we have to draw these 2 construction lines over here. So once we draw these 2 construction lines, so we will be able to establish relationship between point M projections in the front view as well as in the left hand side view. So now we are required to establish the relationship between the front view projections corresponding to the point L and the side view projections corresponding to the point L over here. So for that purpose we need to draw these 2 construction lines so that the similar relationship between the front view projections corresponding to the point L and the side view projections corresponding to the point L can be obtained over here. And finally we are required to draw these 2 projection lines so that we can establish the interrelationship between the top view projections corresponding to the points L and M and the side view projections corresponding to the points L and M in the side view. So this way we have been able to establish the relationship between front view projections, top view projections and the left hand side view projections in the 3D spatial environment over here. Now let us proceed to evaluate the 2D orthographic projections corresponding to this particular line LM over here. Now we know that since this line happens to be parallel to the vertical plane, so first of all the first projections we are going to draw will be the front view projections. And another thing we remember that in the front view we are going to obtain the true length projections corresponding to this particular line LM onto the vertical plane. So we know that point L, it is located 25 millimeter above the horizontal plane and it is located 10 millimeter in front of the vertical plane. And this line LM, it is inclined at an angle of 40 degree with respect to the horizontal plane. So here we can check the location of the point L. It is 25 millimeter above the horizontal plane or above the XY reference line. So we know that this line LM, it is inclined at an angle of 40 degree with respect to the horizontal plane. So the angle theta equal to 40 degree. So this angle of inclination has been provided to us. So once we mark this angle of inclination equal to 40 degree, then we can go about the construction of this line L dash M dash, which represents the true length of this line in the front view orthographic projection. So therefore L dash, M dash, true length front view projections, they have been obtained onto the vertical plane. So using the orthographic projections of the points principles, so we know that wherever L dash point is located onto the same vertical projection line, the projection corresponding to the point L will be located over here. Similarly, wherever projections of M dash they have been located onto the same vertical projection line, the projections of the point M will be located onto the horizontal plane. Now, when we are going to look at this particular line LM from the top, so we observe that because of the inclination of this line LM with respect to the horizontal plane, we are going to obtain a foreshortened or reduced length of the line as a projection in the top view projection, that is LM. So this length will be foreshortened or the apparent length projection of the line. And where it will be located? It will be located at a distance of 10 millimeter in front of the vertical plane. So 10 millimeter in front of the vertical plane means that because of the clockwise rotation of this horizontal plane, so this 10 millimeter distance in front of the vertical plane will be located 10 millimeter below the XY reference line. So let us measure this distance 10 millimeter below the XY reference line. And moment we measure this distance 10 millimeter below the XY reference line, so now 10 millimeter below the XY reference line, we are going to obtain the projections corresponding to the top view of this line LM, which will be obtained as the foreshortened projections or the apparent length projections, and these projections will be drawn parallel to the vertical plane because this line happens to be parallel to the vertical plane. So the projections L and M, they will be located at a distance of 10 millimeter below the XY reference line. So we have been able to obtain the front view projections of this particular line, the top view projections of this particular line, and now we are required to evaluate the horizontal trace of this particular line. So in order to obtain the horizontal trace of this line, please check the procedure. Here we have been able to obtain the front view projections of this line L dash M dash. So we are required to extend this projection L dash M dash line in such a way that it intersects with the XY reference line at a point H dash. So please check, while we were discussing the evaluation of the horizontal trace using the spatial coordinates, so we had extended this line LM first of all. But in the case of orthographic projections, this spatial location of the LM line, it is not available with us in the 2D projection. So what we have to do? We have to extend this line L dash M dash in such a way that it should be extended to meet the XY reference line to obtain point H dash. And wherever we are getting this location of this point H dash, from point H dash, we have to draw a vertical projector line in such a way that this vertical projector line should be meeting the plan projection line itself or its extension in the 2D orthographic projections over here. So please check, we have extended the elevation projection line L dash M dash such that it should be meeting the XY reference line at the point H dash, and from point H dash we are going to draw a vertical projector line in such a way that this vertical projector line, it should be meeting or intersecting with either the plan projection line itself or its extension over here. This vertical projector line, it does not meet the projections corresponding to the plan projection line. So what we have to do? We have to extend this plan projection line and draw a horizontal locus line through the points L and M such that this horizontal locus line, it should be intersecting with the vertical projector line which has been drawn through the point H dash. So wherever this point of intersection is obtained, so we will be able to locate point H in the plan. And now this perpendicular distance of the point of intersection of the line with the horizontal plane and the XY reference line will be providing us with the measurement of the horizontal trace of this particular line. So here, once we measure this distance H dash and H, so we find that the horizontal trace of this line LM, it is equal to 10 millimeter. So the horizontal trace has also been located, front view has been obtained, and the top view projections, they have also been obtained. Now we are going to proceed with the evaluation of the left hand side view projections corresponding to the line LM. So we see that here the line LM is being observed by the observer from the left hand side. So the projections, they have been obtained on the profile plane which is located on the right hand side. So in the first angle projection method, the left hand side projections of any given object, they are obtained on right hand side of the front view projections. So in order to obtain the left hand side view projections onto the profile plane, so now we are required to extend this plan projection line LM in such a way that it should be extended to meet the X1 Y1 reference line at this particular position. So the moment we obtain this point corresponding to the horizontal locus line which has been drawn through the points L and M, now we have obtained this distance of this line from the vertical plane. And how much is this distance? This distance happens to be 10 millimeter. So since this line happens to be at a distance of 10 millimeter from the vertical plane, now we need to transfer this distance of 10 millimeter from the vertical plane onto the profile plane. So how this transfer will be done? This will be done by using this transfer technique. So this transfer arc has to be drawn. So how this transfer arc we are going to draw? So we'll keep the needle point of our compass at the point of intersection of the two reference lines, that is XY reference line and the X1 Y1 reference line over here. So wherever these two reference lines they intersect, we'll have our needle point. Open compass is equal to this distance corresponding to 10 millimeter in front of the vertical plane, and open this much arc and then draw an arc which will transfer this distance of 10 millimeter in front of the vertical plane into the profile plane. So once we are able to transfer this distance of 10 millimeter in front of the vertical plane into the profile plane, so we are going to draw a vertical projector in the upward direction in such a way and extend it up to the point till it meets the horizontal construction lines which are going to be drawn towards right hand side direction, emerging from points L dash and emerging from point M dash over here. So wherever this intersection with the horizontal locus line which has been drawn through the point L dash, so wherever this intersection is obtained, we will be obtaining the point L double dash in the side view. Similarly, wherever this vertical projector line, it intersects with the horizontal locus line which is drawn through the point M dash, so this intersection of the horizontal locus line with this vertical projection line, it will provide us with the location of the point M double dash over here. So L double dash has been obtained, M double dash has been obtained. So the 2 points corresponding to the apparent length projection of the line in the left hand side view has been obtained onto the profile plane. So since this line LM happens to be inclined to the profile plane as well. So therefore, the projections which we have obtained onto the profile plane, that is L double dash and M double dash, they represent the apparent length or the foreshortened view projections of the line LM onto the profile plane. So this way we have been able to obtain the front view orthographic projections, the top view orthographic projections, and the left hand side view orthographic projections corresponding to the line LM. And besides this, we have also evaluated the traces of the line. So this is all for today. So I hope that through this discussion you would have understood about how we can go about providing the spatial coordinate location of the line which happens to be inclined to the horizontal plane and parallel to the vertical plane with respect to the three reference planes, that is HP, VP and PP. And we have also been able to evaluate the orthographic sections of this line, that is front view, top view and left hand side projections of this line. And we have also evaluated the traces of this particular line into the horizontal plane and the vertical plane. So we'll be continuing with further discussion regarding orthographic projections of the lines in the coming lectures as well. So thank you very much. Thanks a lot.